Okay, students, I'll introduce this idea of function combinations. I'll try to do this as quick as possible with the least words. The general idea of this is that we have more than one function in a given situation or in life, and we need to combine functions together. An example would be you're going to the store and you're going to buy a pair of pants and they're on discount, but even after the discount, you're going to have to apply a sales tax. So you got to do this first, like 85% of the original cost, then apply the sales tax. You could think about your paycheck. Your paycheck, you have your gross, and then depending upon what your gross is, your Social Security is taken out. Or perhaps you're thinking about your income tax. On your income tax, you got to put a lot of um, reporting of your income, and then you have your adjusted gross income. Then, based upon that, you have your um, you have your tax. You got to go to the tax rate table and find your tax, and it is conditional upon your income. And so you recognize that sometimes when you're doing a financial computation, you'll have a computation that happens after another computation. Or maybe you're an athletic person and you're trying to improve your body, so you have your heart rate, but your heart rate, it's important, but you have to have that heart rate above a certain amount for a certain period of time to receive a certain benefit. Hopefully that makes sense. Now, the general idea of a function, we're going to use this box as an illustration. I'm going to plug in 2. I'm going to get back out 6. I'm going to plug in a -5. I'm going to get back out -15. That makes sense? What if I plugged in a x? What if I plugged in a a plus 2? I would get back out 3 times a plus 2, or 3a plus 6. Now what we're going to do is we're going to take one function, f, and then add another function to it. So let's see. Let's move these things out of the way and I'll do a little illustration. We're calling this function operations. Function operations. So here's 2, f and g. Now I want to know what f of 2 plus g of 2 is. Well, take the 2, plug it in for the f, and you get back out 5. Okay, so this part's 5. Now take a 2 and plug it in for g. 2 goes into g. Remember, g is x squared, so 2 squared is 4. So g of 2 is 4. So what is f of 2 plus g of 2 is 5 plus 4, which is 9. Okay? Now, the idea of f of 2 plus g of 2 is can be written this way, f plus g of 2. We can add, we could subtract, we could multiply, or we could divide. So in this case, it would be 5 minus 4, which is 1. In this case, it would be 5 times 4, which is 20. In this case, it would be 5 divided by 4, which is what? 1.2. Function operations. That is what we're talking about. Now, what I'm going to do is I'm going to remove our little notations here, and I want to know what this is. I want to know in general, what's f plus g of x? So that's not a specific question. It's saying take f, which is x plus 3, and add to it g, which is x squared. You're adding the two functions together. So that would be x squared plus x plus 3. All right. So keep in mind, we could add, we could subtract, we could multiply, and we could divide. Let's do a divide. I want to know what f over g of x is. I should probably write it like this, okay? F over g of x. That is going to be x plus 3 over x squared. Now, keep in mind that the domain of this is all real numbers. The domain of this is all real numbers. But the domain of our function operation is not all real numbers. Remember, you can't have a 0 at the bottom, so the domain would be x cannot equal 0. Function operations. That is the gist. Just be careful on setting up and working your problem. Look at the examples. Now, I want to take a moment and talk about function composition. Now, this is a function within a function, kind of like Ezekiel saw a wheel, a wheel in the middle of a wheel. All right, so a function composition, f is x plus 3 and g is x squared. I want to know what f composite g of x is. This symbol means composite. It simply means this, f of g of x. That's all it means. Well, let's do an example. I'm going to call this fog, okay? What's fog of 2? That means take a 2 and plug it in for g first. If I plug it in for g first, what do I get back out? I get a 4. Now, I'm not adding like I did the last time. No, I'm wanting to know. I did this. Here's what I did: f of g of 2, but g of 2 is 4. So what is f of 4? I'm taking my number, plugging in there, and getting 7. So fog of 2 is simply 7. Notice I didn't put the numbers in them separately and add them together. I just ran a number right through my functions one after the other. Now, fog and golf. What is golf? Golf is g of f of 2. What does that mean? It means I take the number 2 and I plug it in for f. So here's 2. I'm plugging it in for f. What am I going to get back out? Well, I'm going to get a 5. All right, so what is g of 5? That means take the 5, plug it in for the g, and I'm going to get 5 squared, which is 25. Now notice that these processes are not associative, okay? 7 is not equal to 25. Okay, hopefully that makes sense. Now, the last thing that we need to mention is this idea of function decomposition. Okay, I know it sounds like a CSI movie or something like that, but basically what we're doing is we're trying to identify pieces of function. Pieces of a function. So you notice here in this radical problem, we have 2x plus 1. I could call one function 2x plus 1. Okay? Now I'm just going to call that blah. All right? What function do we have now? We have a square root function. So h of x is really equal to g of f of x. Let's make sure that we got that, okay? What would g of f of x be? Well, I'm starting with f of x, which is 2x plus 1, and I'm plugging it in for g. And in g, the x is right there, so I'm going to plug this in for here. So h of x is equal to the square root of 2x plus 1, which is what we had originally, which you cannot see. There you go. These are the general ideas related to this particular lesson, and I do hope that that makes sense to you.